Math 13 students. This is the final installment in the 8.1 material. This is where we're going to try to put it all together, and I'm going to give you a couple of different methods. We'll actually run through the details when I get into the 8.2 and the 8.3 material, but we're going to set out the actual methods we use to handle the hypothesis test right now. So please come with me to the different screens. All right, 8.1, hypothesis test methods. At the end of the day, we have two distinctly different approaches. They are utterly and completely equivalent, but they are two different approaches, and they each actually have their place. The first method is what we call the traditional method. And as you might imagine, this traditional method has been around for a while. It's also called the critical value method also. And the second method is called the p-value method. Now, this p-value method is currently what people use. It's what we use right now. It's used by the professionals. And anytime you read anything on statistics, anytime any statistical result is conveyed, it will be conveyed via a p-value. So it's really the way to go about doing this. I do like the traditional method because it is visual. Pictures are good. It uses the test statistic, which we've talked about, and it uses the critical values and the rejection region. So those things really kind of make it very useful. As I said, for the p-value method, it's what the professionals use. It is essentially pretty simple by comparison. Now, what do I mean by simple by comparison? Well, at the end of the day, we just compare two numbers. Should be easy, should be straightforward. However, it is not visual. So we have two distinctly different approaches. They do not give you any different results at all. They are entirely equivalent, but they are quite a bit different. This traditional value method, I like that a lot because it is so visual. So at the end of the day, I like this for the first examples. So for first examples, I really truly like the traditional method. And you'll see me do one of those pretty much in the next couple of sections, one for each section. But after I run through that first example, after we get there, I'm going to take a look then at the p-value method. The first thing we'll do is we'll see how our calculator works with that. But after the first example, all others will be handled with the p-value method. And you'll see a lot of examples with that. Now, let me go ahead and just give you the basic recipe for each one of the approaches because there is a lot of overlap. I mean, they do answer the same question. So, for the traditional method, the first step to do is to write the null and the alternative hypothesis. I'll take and I will draw the distribution with the rejection region and any critical values. I will then calculate and plot the test statistic. Once I've done that, I can then go ahead and I can determine the outcome of the test. That would be to reject or fail to reject that null hypothesis. And then finally, I address the initial claim. So we have 1, 2, 3, 4, 5 steps to statistical nirvana if we use the traditional method or the critical value approach with the rejection regions. Now, if we take a look at the p-value method, here's what we're going to do here. We're going to write the null and the alternative hypothesis. We're going to calculate the p-value. I'll compare that p-value with alpha. I will determine the outcome, and I will address the initial claim. 1, 2, 3, 4, 5. 5 steps again to statistical nirvana. I will point out that step 2 and step 3 in the traditional method are a bit different than step 2 and step 3 in the p-value method, but that's really where they differ. And I'll remind people that if you go back and you take a look at the discussion of the p-value, you'll see that the p-value and the test statistic have a lot to do with each other. Other than that, it's pretty much identical because you are answering the same question. So you will soon see me run through some examples of both of these methods once we get into the material in 8.1. Goodbye for now. Bye-bye.